Hello everyone, this is Yu from class Hw5 Q2. In this video, I will solve question 2 of homework 5. We have been given that fxy equals to 1 divided by a times y squared times x, and we also know the range of x is larger than 1 over y and less than y, and y is greater than 1. For the first question, we should draw the non-zero definition region of fxy. Then we will use some baselines. Since y is larger than 1, then our baseline could be y equals to 1. And x is ranging from 1 over 5 over y to y. Then we have two baselines. One is y equals to 1 divided by x, and the other one is y equals to x. The intersection of these three lines is the definition region of fxy. Now let's look at part 2. To find a so that fxy is a valid joint density function. In order to find a valid joint density function, we have to use the definition of validation that the integral of fxy dx dy equals to 1. In this problem, we should do the integral from the infinity, from 1 to the infinity, and the integral from 1 over y to y. 1 divided by a times y squared times x dx dy equals to 1. And after solving this problem, we can get a equals to 2. This is the answer for part 2. Then in question 3, to find and draw the marginal density function of fx and fy, in this problem, we need to use the definition of a marginal function. That is, fy equals to the integral from minus infinity to infinity fxy dx. And because we have already know the range of x and the value of a, then this equation equals to integral from 1 over y to y, and 1 divided by 2 times y squared times x dx, and that should be ln y divided by y to the power of 2 when y is greater than 1. And this is the marginal function of y. Then the marginal function of x should be the integral from minus infinity to the infinity fxy dy, and this should be the integral from x to the infinity 1 over 2 times y squared times x dx. When x is larger than 1, and the answer should be 1 over 2 times x squared. Now let's look at the condition when x is ranging from 0 to 1. We have the marginal function of x equals to the integral from 1 over x to the infinity 1 divided by 2 times y squared times x dy. Then the answer should be a half. Now finish this part. Let's look at the last part of this question. We need to verify f(x) and f(y) are valid density functions. For this problem, we need to use the definition of validation. That is the integral from minus infinity to the infinity fy dy equals to 1. Similarly, the integral from minus infinity to the infinity fx dx should also be 1. Now, for equation 1, it equals to the integral from 1 to the infinity ln y over y squared dy equals to 1. And for the equation 2, it equals to the integral from 0 to 1 a half dx plus the integral from 1 to the infinity 1 over 2 times x squared, and it also equals to 1. Therefore, the function of fx and fy, they are both valid. Thank you. This is the answer for the question 1.